Let's look at example 3. It says graph the following lines, and this time in A we have y equals 1/2 x minus 4. Remember, when a line, an equation, is in y equals mx plus b form, it tells us two things. This tells us the slope, and this tells us the y-intercept. So what I know is that the slope is 1/2, and that the y-intercept, which is b, is equal to the point 0, -4, and now I can do it just like the last one. And I think I'm going to put both of these on the same coordinate grid. So we've got the point 0, -1, 2, 3, 4, and my slope is 1/2, positive. So what's that mean? It means up 1, right 2. So we're going to go up 1 and then right 1, 2. And I can graph that line very easily. Okay, let's look at B. We have the equation 4x minus 6y equals -36. Rather than doing an xy table, I want to get this arranged into y equals mx plus b form. So I'm going to subtract a 4x from both sides. I have -6y equals -4x minus 36. Now I'm going to divide each piece by -6. And we get y equals positive 2/3 x. I just simplified plus 6. So what am I told? This tells me that the slope is 2/3, and this tells me that the y-intercept is the point 0.06. So 1, 2, 3, 4, 5, 6. There's the y-intercept. And the slope 2/3 means it's positive, up 2, right 3. So from that point, I'm going to go up 2 and right 3, and I'm right there. And I have that line. Okay? Okay, let's take a look at equations of lines. The bottom third of your guided notes on the back of the first page, it says each line is uniquely determined by its slope and its y-intercept, meaning every line that you graph has one unique equation. There's 3 forms of the equation, 2 of which we're going to be using. The other one, not so much. So we've got what we call the standard form of a line, which is ax plus by equals c. We have the slope-intercept form of the line, which is y equals mx plus b. That's the one I always use. And then we have the point slope form. You won't see me use that much, but I will do some examples for you. Y minus y1 equals m times x minus x1. I just think it's easier to use this one. But we'll do it both ways. So let's look at example 4. It says we're supposed to find the equation of the line that has a slope of 4, and it contains the point 1, 2. So that's our x and our y. Okay? You may use either the slope-intercept or the point-slope form of a line. So I'm going to do it both ways, and you can decide which way you like it better. So let's do the point-slope form first. So we're going to call that PSF, point-slope form, and this is slope-intercept form. Okay? Point-slope form. Here's what we know. We know that m is 4, x1 is 1, y1 is 2. We only have one x and one y. So we're going to take it into our generic equation. Y minus y1 equals m times x minus x1. But you're not finished. So now you have to distribute and rearrange. So we would end up with y minus 2 equals 4x minus 4. Add a 2 to both sides, and you get y equals 4x minus 2. So notice, even when you start out in point-slope form, you end up in slope-intercept form. Now, let's do the other way. Let's do it using slope-intercept form. From the beginning, I would still list what I know over here. My x1, my y1, my m, and I need a b in order to write that. So my x1 is 1, my my y1 is 2, my slope is 4. I was given that. B, I don't know. It's what I'm looking for. So we're going to use the formula y equals mx plus b to find the b. So y, 2, equals m, 4 times x plus b, or 2 equals 4 plus b. Subtract a 4, and I know that b is negative 2. So I'm going to fill that in. Now that I found that, I can now put it in the correct form of y equals the m that we know times x plus the b. And I get the exact same thing. And you know, some information works better with point-slope form, and some information works better with slope-intercept form. It's sort of a matter of preference and depending on what information that you're given. So let's look at example 5. We're going to go through it the same way. Find the equation of the line that goes through these 2 points, the point 2, 3, and the point negative 4, 5. This time we don't know the slope, so we have to find it. So we know we're going to label x1, y1, x2, y2. The slope, no matter which form you use, you have to find slope first, is 5 minus 3 over negative 4 minus 2 equals 2 over negative 6, which if you simplify is negative 1/3. So I go over here in the margin for this one, and I can use either one of the x's and y's that I want. I'm going to use this one because it's positive. So x1 equals 2, y1 equals 3, m equals negative 1/3. On this one, I don't have to find b. So I write, for point-slope form, I write y minus y1 equals m times x minus x1. So y minus 3 equals negative 1/3 x, a negative times a negative is positive, plus 2/3. Now I have to add a 3 to both sides, so you've got to be able to add fractions. And we get y equals negative 1/3 x. How do you add 2/3 and 3? I change 3 to 9/3, common denominator. So I end up with 11/3, and I have it. That's point-slope form. Now let's do it with slope-intercept form. Again, we're going to start with an x, S2, a y, S3. We would have had to find our slope the same way we did right here for the other form. So I already know it's negative 1/3. And now I need to find b. So I'm going to go y equals mx plus b. 3 equals negative 2/3 plus b. Add 2/3 to both sides, and I get b equals 3 over 1 plus 2 over 3. Find a common denominator, which is 3, and you get b equals 11/3. So now we have to write the equation. Y equals the m that you found times a generic x plus b. Oops, I forgot the plus here. So we end up on both equations with the same thing. It's just, again, a matter of preference. In this instance, I actually think slope-intercept form was easier. In number 4, I think point-slope form was easier. It's nice to know them both.